So our last and final test will be the root test. And the root test is, like the ratio test, the root test is nice because it will tell us whether a series is absolutely convergent. So let's say we have this series from n equals 1 to infinity of -1 to the n, 5 to the n over n to the n. So using the root test, there's three possibilities. So for the root test, we're going to take the limit as n goes to infinity of the nth root of the absolute value of a sub n. And then that limit is going to equal some number L. And our possibilities are that L is less than 1. And if that's the case, the series converges absolutely. If that limit L is greater than 1, the series diverges. And the third possibility is that L is equal to 1, and that means the series is, that the test is inconclusive. So let's apply that test to this given series here. We're going to take the limit as n goes to infinity of the nth root of the absolute value. So if I'm taking the absolute value of -1 to the nth power, 5 to the n over n to the n, then this -1 to the n it doesn't matter, it has no effect on this limit. So we can ignore that -1. And then we'll take the limit as n goes to infinity of, we'll have 5 to the n over n and n to the n over n. And so that will be the limit as n goes to infinity of 5 to the first power over n to the first power. And that limit will equal 0, which is less than 1. So the series converges absolutely. So we'll look at another example. Let's say I have the series from n equals 1 to infinity of 2 to the n over n to the 10th power. So I'll take the limit as n goes to infinity of the nth root of the absolute value of 2 to the n over n to the 10th. That's going to simplify to the limit as n goes to infinity of the absolute value of 2 to the n divided by n over n to the 10 divided by n. And so when you're taking the limit as n goes to infinity, we'll have 2 over n. The limit is as n goes to infinity of 10 over n is going to be just n to the 0 power, which is equal to 1. So this limit will equal 2, which is greater than 1. Whoops. So this series diverges. So we've had a lot of tests. Let's talk about general strategies. Oops. General strategies for testing series. The first thing we want to do is take the limit as n goes to infinity of our nth term. If that does not equal 0, or if it equals infinity, then it diverges. We're done. You're going to stop there. So that's the first thing we want to do. The second thing we want to ask, is it any kind of a special series? Is it a special type of series? So is it geometric? Is it a p-series? Is it a telescoping series? Or is it an alternating series? So if it's any one of those four, you should know what kind of series you wanna use, what kind of test you want to use. Third, can we use the ratio or root test and then fourth, I would say, can we compare to another test, to another series rather. So can we use limit comparison or direct? If all that fails, treat a sub n like a function and use the integral test. And that's going to be your general strategy for testing series.